Okay, so what we're going to do now is called implicit differentiation. And the reason why I really like this particular lesson is because it, I think, helps consolidate some of the math stuff for more complicated problems. With what you know right now for this first problem, what you would have to do is take all of the y's and get them by themselves on one side and then try to solve. But that is a really ugly equation. So instead, we use something called implicit differentiation, which means we're going to take the derivative of each term at that very moment. So when I look at this one, I have the derivative of 2, it just goes away. As far as negative 4y squared, we're going to follow the same pattern as if it were an x. So we would have negative 8y. But at the end, since we took the derivative of y in respect to x, we have to write it here at the end. Now that might look weird, but I'm going to leave it there like that. The next one, we take just like we always have, we would have 9x squared. Technically, what we're doing here is doing the derivative of x in respect to x. But when you have dx divided by dx, it just cancels out. So we're just left with 9x squared. So technically, you've been doing this the whole time. You just didn't know you were. All right, so I'll continue. This would be equal to 3. And then the y goes away, but we still have to include that dy dx. And then the last one will be minus 15y squared dy dx. Okay, we're still not done because we have to solve for dy dx. So the second step is to get everything with a dy dx onto one side of the equation. So I will do that now. So I would have, I'm just going to move the negative 8y to the other side because it's a little bit easier. Whoops. So I will be left with 9x squared is equal to 3 dy dx minus 15y squared dy dx plus 8y dy dx. Now, what you'll notice about the right side of this equation is that every single term has this dy dx. So now I can factor it out. So now I will be left with 9x squared equals dy dx times 3 minus 15y squared plus 8y. Lastly, to get that dy dx by itself, I just have to divide the 9x squared by that whole, both sides, by that whole term. So what I end up with is that dy dx is equal to 9x squared divided by the quantity of 3 minus 15y squared plus 8y. This still feels tedious, yes, I know, but it's not nearly as bad as if you tried to solve that last equation, the first equation by hand. So now we'll try it again. Here we go. We have, give myself a little bit more room this time. Okay, so the first side, I have negative xy. Now I still have to use product rule because those are being multiplied. So I have negative x times the derivative of y, which is dy dx, plus y times the derivative of x, which is just negative 1. And that's going to be equal to, the 4 goes away, but then I can bring down, I have negative 15y squared, but at the end, I can't forget my dy dx. Okay, so now I need to make sure that I get everything with a dy dx on one side of the equation. So I am left with negative y is equal to negative 15y squared dy dx plus x dy dx. Okay, so now here I can look at my dy dx's and factor them out. So I'm left with negative y equals dy dx times negative 15y squared plus x. So my final answer is that dy dx is equal to negative y divided by the quantity of negative 15y squared plus x. And that's it. Okay. Our very last one, again, now you get to combine your knowledge about chain rule. You can add your knowledge about chain rule in here. So if you want to try it on your own, you can. If so, pause the video because I'm about to start doing this problem as well. So here, in terms of chain rule, what I'm left with is I will have 5 times x cubed plus 3y to the 4th power. It's the first step of chain rule. And then I'm multiplying times the derivative, which would be 3x squared plus 3. And then the derivative of y in respect to x is dy dx. That's going to be equal to 12y squared dy dx. Okay, so again, I'm going to try to now, just in order to save a little bit of time, I'm going to use the binomial expansion theorem, which I'm pretty sure y'all haven't learned yet, but I know it. Otherwise, you would have to multiply this out to the 4th power. But I'm going to go ahead. You can multiply the 5 times the 3x squared term. So we have 15x squared plus 15 dy dx. And then that's being multiplied times. And then this is just a long polynomial. It's a trick. The binomial expansion theorem just helps me know what I'm supposed to be doing. Okay, so once you have it multiplied out, then you just have to distribute this first term. I'm personally not going to distribute this first term because it doesn't have a dy dx. I'm just going to leave it as that quantity. But I do have to distribute this 15 dy dx. I'll do that real quick. Okay, I know this is ridiculous, but I'm actually going to erase a lot of this, and I'm too lazy to edit the video. But since y'all don't know binomial expansion theorem, I feel like I should show you how to do it the faster way. So I'll do that. So what I'm going to do is just leave it totally unsimplified. Just to make this super easy. So I'm just going to distribute the terms. So here I have 15x squared. And we're going to distribute that times the x cubed plus 3y to the 4th, like this. And then we're going to add the 15 dy dx times this whole thing. This will make it neater for y'all anyway. Plus, I don't think IB will ask you to solve one like this with values. So we can leave it unsimplified is equal to 12y squared dy dx. Okay, so same thing as before. I'm just going to move the things with the dy dx to the other side. So from here, I'm left with 15 x squared times the x cubed plus 3y raised to the 4th power is equal to 12y squared dy dx minus 15 dy dx times the quantity of x cubed plus 3y to the 4th. Okay, so from here, I can still continue to factor out the dy dx. So now I am left with 15x squared times x cubed plus 3y raised to the 4th power is equal to dy dx times 12y squared minus 15 times the quantity of x cubed plus 3y to the fourth. Okay, so from here, I then get to divide. So I am left with my final answer of dy dx is equal to 15x squared times the quantity of x cubed plus 3y raised to the fourth power divided by the quantity of 12y squared minus 15 times the quantity of x cubed plus 3y raised to the fourth power. So that's it. Those are your notes. Those are the most complicated ones. I think I am only going to assign one of this bottom one on Delta Math, but a couple more of the other ones, the ones you're more likely to see on your IB exam. So that's that. Awesome.